Hello students. Okay, we are going to start today this numerical problem of order of reaction. If you remember in my last class, I explained you about types of order of reaction. Then I gave you the types of order of reaction. Then I help you out to find the units of rate constant for different orders of reaction in my last class. So in this class, I'm going to solve the numerical problem of order. Okay, there are two ways of solving the problem. Okay, one is tabular form, one is without tabular form. So first we'll be solving the sum of order from tabular form, then after we'll be solving without tabular form. Then we'll start a new topic called molecularity today. Thank you very much. Okay. So this is one question which has come in your board exam in ISC 2012. Okay. The question says, a study of chemical kinetics of a reaction A plus B arrow product gave the following data at 25 degrees Celsius, and this is the tabular form to solve order. And the question is saying you to find the order of reaction with respect to A, the order of reaction with respect to B, and the rate law. Okay, and this is for 3 marks. Now, whenever such question comes in your board exam, first you have to suppose the rate law. Since the reaction given to you is A plus B gives you product. A plus B gives you product. So, to find the rate law order, first you have to suppose the rate equation. So, I am supposing the rate equation this way. Let the rate equation be, we are supposing the rate equation, let the rate equation be R is equals to K. Whenever you suppose rate equation, students, you need to write R is equals to K first, okay? This is rate of reaction, this is rate constant. Then we write on the product of the concentration of the reactants. So this dot indicates product of the molar concentration. Square bracket means molar concentration of the reactant. And if you see here, the reactant is A and B. The reactant is A and what? B. Now, since we are supposing the rate law, means we don't know the order. So let us suppose the order of A is X and that of B is Y. We are supposing. Okay. So I'm supposing this as a rate equation where I don't know the order of A and B, and I'm supposing them as X and Y. Let this be equation 1. Now you need to put the value of R, A and B from the tabular data given to you one by one in this equation. Okay. In first equation, if you see here, students, d product by dt means rate. Okay, rate is given, concentration of A and B is given, that we are going to put one by one, okay, in this equation. So the first one, the value of rate for the first one is 4.20 into 10 to the power minus 6. Okay, the value of R for the first experiment. K we don't know. Concentration of A is given as 1 to the power of X into B is given as 0.15 to the power of Y. Let it be equation 2. So here I put the value of experiment 1. Similarly, now we'll put the value of experiment 2 again in the same equation. Okay. For second equation, the rate is given 8.40 into 10 to the power minus 6. 10 to the power minus 6 is given. Okay, is equals to K. And concentration of A is given 2 to the power of X. I am putting out here. And B is given 0.15 to the power of Y. Let it be equation 3. So similarly, now we'll put the value of R, A and B of the third experiment. In third experiment, the value of R is given 5.60 into 10 to the power minus 6. K is K. The concentration of A is given 1 to the power of X. And B is given 0.20, and the power of this is Y, and this is equation 4. Now students, we need to solve these three equations in order to find X and Y. So if you see out here, the concentration of A in equation 2 and in equation 4 is same. 1 to the power X, 1 to the power X. So if I divide these two, our X will get cancelled, whereby we get the value of Y. Similarly, in equation 2 and 3, the value of Y is same. You can see here the value of Y is same. So if I divide these two, Y will get cancelled and will get X. So you can divide any at first. So now what I am doing here is dividing equation 2 by 3. I am going to divide equation 2 by 3. So what is equation 2? 4.20 into 10 to the power minus 6 equals to k 1 to the power of x into 0.15 to the power of y, divided by, what is equation 3? 8.40 into 10 to the power minus 6 is equals to k 2 to the power of x and into y is 0.15 to the power of y. So I have divided equation 2 with 3. So when I do so, I can cancel these two because the value is same. Even I can cancel these two. Even I can cancel 10 to the power minus 6 and 10 to the power minus 6. Now what remains here is 4.20 by 8.40, which is exactly double. So this is, it will go by 2 times. This and this will go by 2 times. Similarly here, 1 and 2 power is same. So we can write 1 to the power of 1 by 2 to the power of x, taking power common. Now here also I can write here power 1. Now following the law of indices, since the base is equal, so if the base is equal, you equate the power. So as a result, you get x is equals to 1. As a result, you get x is equals to 1. So we got the order of A. So order of A we suppose as x. Now we got the value as 1. So similarly, try to divide any other two equation to cancel x to get y. Right now we cancel y to get x. Now I'll try to divide such equation where we can cancel x to get y. So if I divide 2 by 4, your x will get cancelled. 1 to the power x, 1 to the power x will get cancelled, because of which we will get the value of y. So now let us dividing equation 2 by 4. So if I divide equation 2 by 4, let us see what we get. 4.20 into 10 to the power minus 6 is equals to k 1 to the power of x into 0.15 to the power of y, divided by equation 4. 5.60 into 10 to the power minus 6 equals to k 1 to the power of x into the value of b is 0.20 to the power of y. So if you see here, 1 to the power x, 1 to the power x will get cancelled, k and k will get cancelled, 10 to the power minus 6 will get cancelled. Now what remains here is 4.20 upon 5.60, that side 0.15 by 0.20 to the power of y, because the power y is common to both. Now remove 2 points from here. So if you remove 2 points, it will become 420 upon 560, and that side if you remove 2 points, it will become 15 upon 20 to the power of y. Okay, now you can see out here, you can cancel this 0 and 0. So what remains here is 42 upon 56, and this side if you cancel with 5, 5 3s are 15, 5 4s are 20, so it will become 3 by 4 to the power of y. Now here again we can cancel these 2 with 7, 7 6 are 42, 7 8s are 56. Again you can cancel this with 2, 2 3s are 6, 2 4s are 8. So what remains now is 3 upon 4 is equals to 3 upon 4 to the power of y. Again here also I can write power 1. Okay, again applying the law of indices, the base is same. So we can equate the power, so y will be 1. So students, we got the order of A as 1, order of B is also as 1. Now the question is saying first to find order of A. So number 1, order of A, which we suppose x, which we got as 1 now. Number 2, they are saying us to find the order of B, which I suppose as y, which again we got as 1. And number 3, they are saying us to find the rate law. Rate law means rate equation. Okay, what we suppose earlier, r is equals to k a to the power of x, x became 1, into b to the power of y, y is also 1, and this gives you the rate law equation. So students, I repeat again, so in the tabular form students, okay, if the tabular form is given, first you have to suppose the rate law. After supposing the rate law, put the value of experiment 1, 2, 3, one by one in that supposition part. Then try to divide any two equations to cancel x to get y, or cancel y to get x, whereby you get the order of A and B. And after getting those order, you put in that equation which you have supposed, you get the rate law. And this question has come in 2012 for 3 marks. Okay, now we will see another question, okay, which came in ISC 2017. The reaction is given to you as 2H2 plus 2NO reversible sign gives you 2H2O plus N2, and the datas are here. Experiment 1, 2, 3 is given to you, where the value of rate nitric oxide means NO and hydrogen is given. The unit of concentration of NO is given in mole liter inverse. Hydrogen is also given in mole liter inverse, and your rate is given as mole liter inverse second inverse. Now the question is saying you to find the overall order of the reaction, the rate law, as well as the value of rate constant, that is K. Now let us see how to solve this. Since in this equation also you have to find the rate law, therefore you have to suppose first. So I am writing this equation for you. 2H2 plus 2NO reversible sign 2H2O plus N2 is given to you. Now you have to find the rate law. So suppose the rate law first. Let the rate law be. You are supposing R is equals to K. First you write R is equals to K. Okay, now into concentration of the reactants. In the table, at first NO is given. Therefore, here also you write NO first. Though in this reaction it is second, but you can write it first. And in the table form, hydrogen is given in the second. So here also we write in the second. So these are the two reactants you can see, NO and H2. Now we cannot write these two coefficient in the power because we don't know the order. So again we'll suppose it as X and Y. So let the order of NO, nitric oxide, be X and that of hydrogen be Y. And let this be equation 1. Now, in this equation, we are going to put the value of R, NO and H2 one by one from the experiment 1, 2, 3. Okay? So now let us see what is the value of R for the first experiment. For the first experiment, the value of R is 4.6 into 10 to the power minus 3 is equals to K. The value of NO is given as 0.40 into the value of hydrogen is given 0.40 Y. Let it be equation 2. Similarly, for second experiment, the value of R is given 8.4. 18.4 into 10 to the power minus 3 K. The value of NO for the second experiment is given 0.80x, and that of hydrogen is given 0.40, and the order which you have supposed is Y, so let it be equation 3. Now similarly, for third experiment, the value of rate is given to you is 9.2 into 10 to the power minus 3 is equals to K. Now the concentration of NO is given 0.40, order we have supposed as X, and that of hydrogen is given 0.80 to the power of Y, equation 4. So students, anytime whenever you have to find the order of reaction, first you have to suppose the rate law, students. Then you will put the value of R, NO and H2 one by one from the table. Okay, experiment 1, 2 and 3. Now as I said you before, now try to divide any two equation to cancel Y to get X, and cancel Y to get X, or to cancel X to get Y. So if I divide 2 by 3 here, if I divide 2 by 3, 0.40 to the power of Y will get cancelled, whereby we get the value of X. Similarly, if I divide 2 by 4, 0.4 to the power of X, 0.40 to the power of X will get cancelled, whereby we get the value of Y. So let us divide, first of all, you can divide any one. So right now I am dividing 2 by 3. So when I divide 2 by 3, see here what happens. This equation 2, 4.6 into 10 to the power minus 3 is equals to K, 0.40x into 0.40 to the power of Y. And equation 3 is 18.4 into 10 to the power minus 3 by K 0.80 to the power of X into 0.40 to the power of Y. I am dividing equation 2 by 3. So if you see out here, we can cancel these two because the value is same. Even we can cancel the K. Even we can cancel 10 to the power minus 3. So what remains here is 4.6 by 18.4. But since they have one point, so remove it. So what we get here is 46 upon 184. Okay, and that side, what you get is, again remove 2 points from both the cases, so you get 40 upon 80 to the power of x. Now here you can cancel this 0, 0. Even 4 ones are 4, 4 twos are 8, so here you get half to the power of x now. And here, these two will get cancelled exactly by 4. 46 ones are 46, 46 fours are is 184. So here remains 1 upon 4. Again 1 upon 4 can be written this way, half square, because 1 square is 1, 2 square is 4, and here will be half to the power of x. Again applying the law of indices, okay, you can equate the base is same, so you can equate the power, so x will come 2. So we got the order of NO as 2. Now we will divide another equation to cancel x to get y. So if I divide equation 2 by 4, you can see here this and this value is same, so this 2 will get cancelled, means x will get cancelled, only y will remain. So now what I am going to do is here is dividing equation 2 by 4. So if I divide equation 2 by 4, let us see students what we get now. Equation 2 is 4.6 into 10 to the power minus 3 is equals to k 0.40 to the power of x into 0.40 to the power of y. Now similarly dividing by equation 4 is 9.2 into 10 to the power of minus 3 is equals to k 0.40 to the power of x into 0.80 to the power of y. So this k and k will get cancelled again, this value will get cancelled again, 10 to the power minus 3 will get cancelled again. Now what remains here is here this 2. So again here in a point number only one point is there, so remove it. So what you get here is 46 upon 92. 46 upon 92 you get. Now in this case again 2 points you remove from both the end, you get 40 upon 80. 40 upon 80 to the power of y. Now here you can cancel these two zeros, and this will get cancelled, 4 ones over 4 twos are 8, so it will become half to the power of y. And here this 46 ones are 46, 46 twos are is 92, so here you get half. So again you can keep the power as 1. So again equating the base, y will come 1. So the order of NO which we suppose x came 2, and order of H2 which we suppose y came 1. Now the question is saying you, number 1, to find the overall order. So therefore your overall order will be x plus y. X value just now we got 2 and y is 1. So if you add them, the order will be 3. So the overall order of the reaction is what, students? 3. Next they have said you to find rate law. What we supposed earlier? There you have to put the value of x and y. So R is equals to k NO to the power x, and x came 2, into H2 to the power of y came 1. So this gives you the rate law. So we got the overall order, we got the rate law. Now you have to find the value of rate constant. So students, to find the value of rate constant, okay, now what you have to do is you have to bring these two down. So as a result what you get, k is equals to r upon NO square into H2 to the power of 1. Now in order to get the value of rate constant equation, rate constant students, you can put the value of R, concentration of NO and H2 from any experiment, but all has to be from the same experiment. I repeat again, to find the value of rate constant, you have to put the value of R, NO and H2 from any experiment, but all three has to be from the same experiment. So I'm going to put the value of experiment 1 along with the unit this time, so because rate constant has unit. So what is the rate for experiment 1? 4.6 into 10 to the power minus 3. And the unit of this is given in the book, is in the question is mole liter inverse second inverse. Similarly, the value of NO for experiment 1 is 0.40 mole liter inverse, the unit whole square, because there is power 2. And for hydrogen it's given again 0.40 mole liter inverse power 1. Now first let us solve the unit. This mole per liter and this mole per liter will get cancelled, students. Now mole square, if it goes up, become mole inverse square. Mole square goes up, become mole inverse square. Now liter minus 2 goes up, become power 2, and second inverse is up only. Now we solve the numbers one side. So this is the value of rate, and now this is the square of 4.2 means how many times? 0.40 into 0.40, and here is also 0.40. Now students, unit we got, and you can verify whether your unit is coming right or wrong. As I said in my last class, if the power of liter is whatever is the power of the liter, add 1 to get the order. Just now we came to know the order of the reaction will be. So since the power of the liter is 2, so add 1, so the order will be 3. That means we are going correct. Now how to solve this? 4.6 into 10 to the power minus 3 is given to you. Okay, this 0 has no value, so just remove it out. Now we have to multiply this. Okay, 4 4s are 16, 16 4s are 64 you write. Now after point how many numbers are there? After point 1 number, 2 number and 3 number. So here will be 10 to the power minus 3. And the unit we have already got is mole inverse square, liter square, second inverse. Now this 10 to the power minus 3 and 10 to the power minus 3 will get cancelled. Now k is equals to remove this point and bring 0 down. So it will be 46 upon 640. Unit will be same. Mole inverse square, liter second inverse. Now let us solve this. Okay, I think it will go with your 2 times. It will be 23, and it will be 1. 2 times to 320. It will be 320. Okay. Now you know how to divide this. You can use a calculator to divide these two. Okay, and the unit will be mole inverse square, liter second inverse. So students, after dividing these two, whatever value you get, that along with this unit will give you the value of rate constant. So this is how we calculate the rate constant from our rate equation. So this is all about question number 2. Now we are going to go with question number 3. And this is little bit lengthier numerical, okay? Because in this numerical, you have to do many things. But just see what the question has to say first. Okay, in a reaction, 2A plus B gives you C and D. And there are 4 experiments given to you, students. And now what you have to do is you have to calculate the rate of formation of D when concentration of A is 0.6 and B is 0.3 mole liter inverse, and the unit of rate this time is given at the end, and that is mole liter inverse minute inverse. Okay, this sum is lengthy, but still don't lose the hope. Now if you see this question nicely, this is the question of order, but they have not asked you to find the order. In the previous 2 sum, we found the order of each, even the rate law, even the rate constant, but in this sum, nothing has been asked to you. But still, if the question has come from chemical kinetics, okay, in a tabular form, always go with the same pattern. Though they have not said you to find order, but you have to find the order. Though they have not said you to find rate law, but we will find that. Though they have not said you to find rate constant, but we will find it. Okay, though the question has not asked you anything like that. So let us proceed in the similar way, the way I proceed the first 2 sum. So in this question, 2A plus B gives you C plus D. Okay, this is the question of chemical kinetics. So let us suppose the order first, though they have not asked you. Let the rate law be. Let the rate law be R is equals to K, concentration of reactants. And who all are the reactants here? One is A, one is B. There are 2 reactants A and B. Let us suppose the order of A to be X and B to be Y. Let it be equation 1. Now you are going to put the value of R, A and B of all the experiment one by one in this equation. So let us put for the first one. The value of R for the first one is 7.0 into 10 to the power minus 3. K is K. The value of A is 0.1 and the value of B is also 0.1. So let it be equation 2. Similarly, for experiment 2, the value of rate is given as 8.4 into 10 to the power minus 2 is equals to K. And the value of A is given 0.3 to the power of X, and your B is given 0.2Y. Let it be equation 3. Now from experiment 3, the value of rate is given 3.36 into 10 to the power minus 1, okay, is equals to k. The value of A is given 0.3x and B is given 0.4y. Let it be equation 4. Now from the last experiment, that is experiment 4, the value of rate is given 2.8 into 10 to the power minus 2, and the value of A is given 0.4 to the power of x and B is given 0.1 to the power of y. Let it be equation 5. Now same like before, though they have not said you to find order rate law, but you proceed in the similar way, okay. Now we have to cancel y to get x or to cancel x to get y. So if I divide equation 2 and 5, you can see here is 0.1 y, 0.1 to the power y, so we can cancel these two in order to get x. Similarly, if I divide 3 by 4, then 0.3x and 0.3x will get cancelled, whereby we get y. So let us go proceed further then. So dividing equation 2 by 5. So when I divide equation 2 by 5, so what is the rate law for equation 2? 7.2 into 10 to the power minus 3 is equals to k. So this is the value. And for equation 5, it's 2.8 into 10 to the power minus 2 by k, 0.4x, 0.1 y. So if I divide these two will get cancelled. This k and k will get cancelled. Okay, now let us solve here. Okay, remove this point, it will become 70 upon 28. Now play with the power. 10 to the power minus 2 goes up, becomes 10 to the power plus 2. And plus 2 minus 3 will give you 10 to the power minus 1. Here remove point from both, so you get 1 upon 4 to the power of x. Now here, if you bring this 10 to the power minus 1 down, it becomes 10. And 10 into 28 becomes 280. 1 by 4x, 0 and 0 cancel. 7 1s are 7, 7 4s are 28. So you get here is 1 upon 4 is equals to 1 upon 4 to the power of x. Again, here we can write the power 1. So equating the base, x will come 1. So we got the 1 value. Now let us divide 3 by 4 so that I can cancel x to get y. So let us divide now, dividing equation 3 by 4. So what is equation 3? 8.4 into 10 to the power minus 2 is equals to k, 0.3 to the power of x, 0.2 to the power of y. Now equation 4 is 3.36 into 10 to the power of minus 1 by k, 0.3x by 0.4 to the power of y. Again, if you see, this rate constant will get cancelled. This 0.3 to the power of x will get cancelled. Now this side, if I take this minus 1 up, becomes plus 1, and plus 1 minus 2 will give you 10 to the power minus 1, and that 10 to the power minus 1, if you bring it down, it becomes again 10, and if you multiply here, it will become 3.6. Up will remain as 8.4. This is how I have solved the power. From here I remove 2 points, so what will remain here is 2 upon 4 to the power of y. Now I am extending this side. So if you remove again point from both the end, it will be 84 by 336. And this side, if I divide, it will be 1 upon 2 to the power of y, because 2 1s are 2, 2 2s are 4. Now 84 and this will go exactly by 4 times. 84 4 is 336. And 1 upon 4 means 1 square whole square. 1 upon 2 whole square, because 1 square is 1, 2 square will give you 4. And this side will be 1 upon 2 to the power of y. So again, equating the base, if you equate the power, y will come 2. So we got the order of A as 1, that is x, and order of B, that is y, as 2. But the question has not said you to find order, but yet we got the orders. Now let us find the rate law then. So therefore the rate law will be r is equals to k, a to the power of x, x came 1, b to the power of y, y came 2. So we got the which law also? Rate law. Though they have not asked you about rate law, but we got the rate law, even the order. Now let us find rate constant k. To find rate constant k, you have to bring this number down. So as you bring it down, what will happen? A to the power of 1, r divided by a to the power of 1, b to the power of 2. In the earlier sum, what I said you now? put the value of R, A and B from any experiment, students, but all has to be from the same experiment. So I'll be putting this all value from experiment 1. Okay, then we'll find the rate rate constant. So now I'm continuing this side, students. Okay, so just now we got the expression K is equals to R, concentration of A to the power of 1, B to the power of 2. Now, in order to find rate constant, you can put the value of R, A and B from any experiment, but it has to be from the same experiment. So I'll be choosing experiment 1 mostly. So you also choose experiment 1 always. Okay. Now, what is the value of R for the first experiment? 7.0 into 10 to the power minus 3, and the unit of this is given as mole liter inverse minute inverse divided by concentration of A is given 0.1 mole liter inverse, and that of B is given 0.1 mole liter inverse whole square, because square is there. Now, this and this will get cancelled. First we find the unit, then we'll solve the numbers. Now mole square goes up, become mole inverse square. Liter to the power minus 2. Liter to the power minus 2 goes up, become liter to the power square, because negative becomes positive, and what is the left is minute inverse. Now to verify whether your unit has come correct or not, just now we came to know the overall order is 1 plus 2, that is 3. So it is a third order reaction, and if you see the power of the liter is again 2 here, add 1, so it becomes third order only. Okay, so that means our unit is correct. Now the value which is left is 7 into 10 to the power minus 3, 7.0 means 7. Now here what remains is 0.1, and here 0.1 square means 0.1 into 0.1. So 7 into 10 to the power minus 3, unit is mole inverse square, liter square, minute inverse. Now down 1. Multiply these all. 1 into 1 is 1, 1 into 1 is 1. Now after point, how many digits? 1, 2, 3 digits is there after point, isn't it? So you have to take the decimal back. As a result, you'll write here minus 3. Why minus 3? Because you have taken 3 decimal back. So this and this will get again cancelled, whereby 7 upon 1 becomes 7, and the unit will be mole inverse square, liter square, minute inverse. So far students, I have done this sum same as that what we did earlier. Okay. Now we got the order, we got the rate law, we got the rate constant, but nothing has been asked in this question. Okay. So if you leave it till here also, if this question comes for 4 marks, you are going to get 3 marks. You're going to get 3 marks, though you have not met the answer. But still you will be getting 3 marks out of 4 if you don't know how to do it from here onwards. So do remember, any question of order you are going to find is first order of the reaction, rate law, rate constant, whether it has been asked or not. Now let us see how to find the required question. Calculate the rate of formation of D when the concentration of A and B is so and so given in the question. So now look out here how I go. Since just a while ago we got the rate equation, R is equals to K, A to the power of 1 and B to the power of 2. This is the rate equation which we got earlier, isn't it? Now, the question is saying you to find the rate of formation of D. So put here D. So this becomes rate of formation of D. Now, rate of formation of D is equals to K. Whatever you got from up, write that value of K here. Then A value you are going to put from the question, not from the table, from the question. A value is 0.6 power 1 and B value is 0.3 whole square because of this 2. Now 7 is 7, 0.6 and 0.3 whole square means 0.09. Now if you multiply these two, you get 4.2 because 7 6 are 42, so it will be 4.2, 0.09. Now if you multiply these two, 9 2s are 18, 1 in your hand, 36, 37. After point, how many digits are there? Check. Here is 2, here is 1, that means 3. So put the point after 3 numbers, 1, 2, 3. So the answer will be 0.378. And the unit of R, no need to derive, it is already given in the question, that is mole liter inverse, minute inverse. The same unit you are going to write here, mole liter inverse, minute inverse, and this will give you the answer. So students, do not panic if the whatever you have practiced will not come in exam, because many students practice how to find order, how to find rate law, how to find rate constant, but they don't expect such kind of questions. So students, if such question comes, no matter they have not said you to find order, rate equation, rate constant and all, but still go with the same pattern and find the order, rate equation, rate constant, and finally, whenever you have to find the rate of formation of D, put the value of K which you have got and put the value of A and B, not from the table, but the given one by the question, whereby you get the rate of formation of D. Okay? Now we'll go with number 4 question, students. And if you see in this question, there is no table given to you. So this is to find order or to find the rate without tabular data. In the first 3 sum, you saw how to calculate order rate equation through tabular data, but here tabular data is not given, but yet we can solve it. Number 4, for the reaction A plus B product, the rate becomes double on doubling the concentration of A, but remains unchanged on doubling the concentration of B. What is the rate law? Since they have asked you rate law, students, so first you suppose the rate law again. So I'm doing question number 4 now. The reaction given to you is A plus B gives you product. And since they are saying you to find the rate law, so suppose the rate law, let the rate law be R is equals to K into concentration of the reactant, and the reactant here is AB, and let the order be X and Y because we don't know, and this is your equation 1. Now what the question is saying, you have to read very carefully. Rate becomes double on doubling the concentration of A. So this rate, question is saying, will become double. So double of R is 2R when you double the concentration of A only. A only. Okay? So 2R is 2R. Take the number out of the equation. So 2 to the power x will come out, and what remains inside is K A to the power of x into B to the power of y. So 2R is 2R, to the power x is same, into, this means what? You can see here this expression and this expression is same, and this means what? R, so put here R. So R and R will get cancelled. I can again consider here the power is 1. So again the base is equal. So power should be equated, so therefore x will come 1. Okay, this is how we find the order of A without tabular data if the question comes. Again, now what the question is saying, the rate remains unchanged on doubling the concentration of B. This rate is going to be double. When you double A, I solve it, I got the answer. Now the second part is saying the rate remains unchanged when you double the concentration of B. So the rate is going to remain same. The rate is going to remain same when you double the concentration of B. The rate is going to remain same when you double the concentration of B as per the question is saying you. Now rate, now here 2 to the power y, take it out. So what remains here is A to the power of x and B to the power of y. Again, if you see, students, this means what? This, and this is equal to what? R. So you can replace this with whom? R. Again, this R and R will get cancelled. So what remains here is 1, and here is 2 to the power of y. Now applying the law of indices, students, since the base here is 2, so I have to replace this with base 2 to the power 0, because you know that anything to the power 0 is 1. Suppose if here was 3 to the power y, here I could have written 3 to the power 0. If here is 4 to the power y, I'll write here 4 to the power 0. Right now it's 2 to the power y, so I'm replacing 1 with 2 to the power of 0, because anything to the power 0 is 1. So again the base became equal, so equate the power, so y is equals to 0. So the order of A came as 1 and the order of B came as 0. And the overall order means x plus y, 1 plus 0 will give you 1. But the question is not saying you to find order, but they're saying you to find rate law in this question. So therefore the rate law will be R is equals to K concentration of A. What was the power of A we consider? X. So x came how much? 1. And B to the power of y. Y is how much? 0. So this becomes your rate law for this particular numerical. Now we go to question number 5. Question number 5. Okay, in this question number 5, students, Again, the rate equation is given to you, reaction is given to you, that A plus B gives you product. Okay, question look huge, but you have to read stepwise to get the answer, and this question came in ISC 2004. Now for this question also, students, what I'll do first is I'll suppose the rate law. A plus B gives you product. The question is saying, in this question you have to find the order as well as the rate equation. So first you suppose the rate law again. Let the rate law, instead of rate law you can say rate equation. Let the rate equation be, R is equals to K concentration of A into concentration of B, and the power will suppose as X and Y. Let X be the order of A and Y be the order of B, equation 1. Now you need to read the question carefully. Now what the question is saying, check here. The initial rate of the reaction doubled. When the initial concentration of A is double, so what the question is saying, the rate becomes double when the initial concentration of A becomes double. They have not said anything about B. Rate becomes double, okay, when the concentration of A becomes double. So just like before, now 2 to the power x, you take it out. What remains inside is K, A to the power of x, B to the power of y. I have just taken the number out. And 2 to the power 2r 2 to the power x into, this means again this, which is equivalent to r. So write r here. So r and r will get cancelled again. So I can write here power 1, again the same. So therefore x will be 1. Order of A will be 1. Now again what the question is saying, the rate increases by 8-fold. The rate increases by 8-fold when the initial concentration of both A and B are doubled. Now the question is saying again, this rate is going to become 8-fold, means it will increase by 8 times when you double both of them. I repeat again, the rate becomes double when you double both of them. So now rate is going to become 8 times, as the question is saying, when the concentration of both A and B are double. Concentration of A and B are what? Double. So this will be 2r, take out the power out here, 2 to the power of x and 2 to the power of y, only the numbers. So what remains inside is this much. Now 8 means 2 cube, you all know that, and here base is same, so add the power applying law of indices, and this means this, which is equal to again what? R and R will get cancelled. Now if you see here the base is same, 2, so equate the power, so 3 is equals to x plus y. So therefore y is equals to 3 minus x, if you bring it this side, and x value we have already got as 1, so put the value of x as 1, so y will come 2. So we got the order of A as well as order of B. Now what the question is demanding you to do, state the order of the reaction with respect to A and B. So order with respect to A, which we suppose x, came 1. Order with respect to B, they are saying us to find, which we suppose y, which came 2. So we got the order of A and B. Now they have even said you to write the rate equation. So therefore rate equation will be R is equals to K concentration of A to the power x, x came 1, B to the power of y, y came 2. So this is the required answer of the question. Clear, students? So this is how we solved question number 5. Okay, this is one objective question which has 4 options. Now we are going to solve this one. Okay. Complete the following statement by selecting the correct alternative answer from the given choice. Okay, these are the 4 options which came in ISC 2007, students. But you cannot solve this randomly. You have to make a rough work. Now if you see, first you suppose the rate equation, R is equals to K, and the reactants are x and y. As per question is saying x and y. And what they have said is, between x and y is first order with respect to x. So the reaction is first order with respect to x. So write power 1. And second order with respect to y. So put here 2. First order with respect to x and second order with respect to y. Now what the question is saying, what will be the effect on rate if the concentration of A is halved, x is halved and y is doubled? So what is going to happen to this rate, okay, if the concentration of X is halved and that of Y is doubled. Question is saying what is going to be effect on rate if concentration of A is halved and that of Y is doubled. That is your rough work. Okay. Now take the number out. 1 to the half to the power 1 is half. 2 square is 4. And what remains now is this much. Y to the power. So this and this will get cancelled. So therefore R is equals to 2k x to the power of 1 and y to the power of 2. Let this be initial concentration, students. Initial rate, sorry. And this is your final rate. So what happened? When you halve the concentration of A and double the concentration of Y, then the rate will become 2 times of the initial rate. It will become 2 times means double the initial rate. Here is 1, but here is 2. So the new rate will be double or twice of that of initial rate. So the answer is double or twice. Now if you see the option 1 is same as the initial value, option 2 is 3 times the initial value, option D the double the initial value, and last one is half the initial value. So for this question, students, answer will be 3, because the rate will become double of the initial value. The rate will become double of the initial value, so the answer will be 3. Okay. Now we will see number 7 question. And good news is this, in this equation, question number 7, rate equation is given to you already. Okay, and they are saying you to find what will be the effect on rate if A is double and B is half. So the rate law given by the question number 7 is R is equals to K A to the power 1 and B to the power 2. Now what will be the effect on rate, the question is saying. Let this be the initial rate. Let this be the initial rate. What will be the effect on rate? Okay. Now if you see, the concentration of A is doubled. So this A will become 2A and that of B is half. So it will become like this. Now what will be the effect on rate if you double the concentration of A and half the concentration of B? So take out the number out. 2 to the power 1 is 2. Half square means 1/4. Half square means 1/4. What remains inside is this much. Okay, and you can cancel these two. So therefore R is equals to half K A to the power 1 B to the power 2. This becomes your new rate. So what will be the effect on rate? If you double the concentration of A and half the concentration of B, the new rate will be half times the initial rate. Here is 1. So therefore you can say new rate will be half times the initial rate. New rate will be half times the initial rate will be the answer for number 7 question. Now the last question, that is number 8. In number 8, again the reaction is given. 2A plus B plus C gives you product. Okay, and the question is saying it is first order with respect to A, second order with respect to B, and 0 order with respect to C. So number 1, what they are saying you to find the rate law or rate equation. So R is equals to K A to the power B to the power C to the power, because we have 3 reactants A, B and C. Now the question is saying first order with respect to A, so put power 1, second order with respect to B, so put power 2, and 0 order with respect to C, so put power 0, and this gives you the rate equation for number 8. Now number 2, what they are saying, what will be the effect on rate on increasing the concentration of A, B, C by 2 times? So what is going to happen to this rate if you increase the concentration of all of them by 2 times? If you increase the concentration of all of them by 2 times, what will be the effect on rate? Now take out the number out again. 2 to the power 1 is 2, 2 square is 4, 2 to the power 0 is 1. Now what remains here is K A to the power of 1, B to the power 2, C to the power 0. Now if you multiply all of them, so we get 4 2s are 8, 8 1s are 8, so R is equals to 8 K A to the power of 1, B square, C to the power of 0. So therefore we can say that the new rate will be 8 times the initial rate. So what will be the effect on rate? Therefore the new rate will be 8 times. You can see from here the new rate is going to become 8 times of the initial rate. So the new rate will be 8 times of the initial rate, and this is all about question number 8. Okay, now we'll see is question number 9. There is a reaction where A gives you product and the value of rate constant is given to you as 5.6 into 10 to the power minus 3 unit is given. Now what will be the effect on rate if concentration of A is halved? So I'm copying from there. The reaction given to you is A gives you product and rate constant is given 5.6 into 10 to the power minus 3. Unit is mole inverse liter second inverse. So you have to explain what will be the effect on rate. Since the order is not given, so let us suppose, let the rate law be R is equals to K concentration of A. Why only A? Because this time the reactant is only A. And the power we don't know, so let it be X. Because order we don't know here. Okay. Now the question is saying what will be the effect on rate when the concentration of A is halved. Okay. So we don't know what is going to happen to the rate if the concentration of A is what? Half. Okay. Now if you take the number out, it will be half to the power X. So that means two things are unknown to us. So why this is given to you then? There might be some clue out here. So students, sometime order may not be given directly. From the unit of rate constant you get the order. So if you see the power of the liter out here is 1. So if the power of the liter is 1, you have to add 1. So it becomes second order. So power will be 2 out here. So students, do remember, if order is not given directly, this is how you are going to find, okay, from the unit of rate constant. Now R is equals to half to the power, half square means 1 by 4. We got it. So what will be the effect on rate? The new rate will be 1/4 of the initial rate. So the answer will be, therefore the new rate will be 1/4 times of the initial rate. So this is the answer. Little bit tricky question it is, because order was not given directly. So from the unit of rate constant also you can indirectly find the order. So liter power whatever is given, add 1, you get the order, put the value here, and the effect of rate is what? It will become 1/4 of the initial when you have the concentration of A. Now number 10 question. Again the reaction is given you as A gives you product. Now what, and it is 0 order they are saying, so therefore we don't have to suppose the rate law. So therefore the rate law will be R is equals to K, A to the power of 0, only one reactant, so A, and the question only has given you the order is 0, so I am not supposing it, I am directly writing 0 from the question. Now to what extent will the rate change if the concentration of A is trebled? Trebled means 3 times. Now what will be the effect on rate? The question is saying when you treble the concentration of A. So R is equals to anything to the power 0 is how much? 1. Anything to the power 0 is how much? 1. So therefore this will be the expression, and if you see this and this expression is totally same, means therefore there will be no change in rate. There will be no change in rate because order is 0. So always remember, whether you double it, triple it, if the order is 0, the rate is not going to change. It is going to remain same. So the rate will remain same, you can say, or the rate will not change. There will be no change in rate, or the rate will remain same, you can say, because the order is 0. So in today's class, I explain you how to find order 2 ways, tabular form and without tabular form, and both usually comes in your board exam, students. So do practice those all. Okay, if you have any problem you can contact me by various means to help you out. So students, go through these 10 numerical problems. Okay, some I taught you for to find order with the help of tabular form, some without. So practice this and try to do as much as questions of this kind from your book. Okay, thank you very much.
Hi, welcome back. So I am taking your class 12 ISC Economics. The last class I gave a gist about what is movement and shift of the demand curve. Today I will explain to you in detail what is movement and shift in the demand curve. So here is movement and shift of demand curve. I will be starting with movement. Now what happens in movement? In movement, you must understand that there is a change in the price. There is a change in the price, and all the other factors like income, like price of related goods, consumer credit facilities, government policies, all these remain constant, ceteris paribus, other factors remaining constant. So there is a change in the price. So if there is a change in the price, obviously there will be change in the quantity demanded. Note that in movement, there is increase or decrease in quantity demanded. Whereas when I teach you shift of the demand curve, I will be saying increase in demand and decrease in demand, not increase in quantity demanded and decrease in quantity demanded. You have to be very clear with that. The next thing is in movement, there is movement along the same demand curve. Same demand curve means the demand curve will not shift. You will be using just the same demand curve, and there is movement along the same demand curve. Let me explain. The first thing I would like to explain is extension of demand. Extension of demand means there is an increase in the quantity demanded. How can the quantity demanded be increased? When the price falls. So you make sure that you decrease the price so that the quantity demanded can increase. Other factors remaining constant. Let's have a look here. So this is your extension and this is your contraction. The first thing in extension you should know that the price will increase. Your price will increase and all the other factors will remain constant. There is no change in the income of the consumer. There is no change in the price of related goods, etc. So your other factors will remain constant. Number 2, if the price is remaining constant and other price is increasing but all the other factors remaining constant, if the price increases, what happens? The quantity demanded should also increase. Okay. There's a small mistake here. The price has to fall, factors remaining constant, your quantity demanded will increase. Price has to fall here, other factors remaining constant. When price falls, quantity demanded will increase. Whenever you see extension, extend means quantity demanded has to increase. When you think quantity demanded has to increase, then price has to decrease. So let's have a look at the diagram. So this is the demand curve, DD. This is the price, let's say in rupees, and this is the quantity demanded. Let us say the price is at P and the quantity demanded is at Q. Now the price has to decrease so that there is increase in the quantity demanded. Price falls. Price falls to P1. So what happens here? We meet here Q1. When the price falls, the quantity demanded will increase. Where were we? We were at A. Now where are we? We are at B. What has happened? When the price fell, the quantity demanded increased. Along the same demand curve, we moved from point A to point B. This is extension. Contraction. Contract means there should be decrease in the quantity demanded. If you want the quantity demanded to decrease, price has to increase. So we start with price will increase. Let us say price increases. When the price increases and all the other factors, factors like your income is same. Price of the related good is same. constant, no change in your income, but the price has increased. What happens when the price increases? Obviously, the quantity demanded will decrease. Price increase, quantity demanded decreases. So if you were to look at a graph, okay, let's have a look at this graph. So this is your demand curve DD. This is your price. This is your quantity, price, quantity demanded. Now, what happens to the price? It should increase. So we'll increase the price. P1. Price increased. Now what happens here? Quantity demanded decreases. So you can see when the price increases, the quantity demanded will decrease. Where were we at the beginning? We are here at A. Now where are we? We are here at C. So we have moved from point A to point C along the same demand curve. Whenever you write the answer in your ISC exams, this is broken up into two parts. If there's a question says that differentiate between extension and contraction, or explain the movement of the demand curve, then you will make it into three parts. You will talk about price fall, factor constant, your price increase, factors constant, quantity demanded increases, decreases, then you explain the graph, and then you can write at the end what is movement? Movement along same demand curve from point A to B. Here what will you write? Movement along the same demand curve from point A to point C. This is movement of the demand curve. Next, the next thing I am going to explain to you is shift. Notice the word shift. Shift means the whole demand curve is going to shift. Either the demand curve is going to shift upwards and rightwards, or it's going to move downwards and leftwards. Let's see. Now, shift takes place when the whole demand moves. The demand curve is going to move. Here, you should note that the price remains constant. The price of the good is same. The price has not changed. So what has changed? Other factors change. This time, all the other factors may change. For example, price of the good is same, but your income has increased. If your income increases, what happens to your demand? There's increase in demand. Note, it should be increase in demand, not increase in quantity demanded. Increase in quantity demanded should be written only in the movement. Similarly, decrease in demand means price is same, but your income has decreased. When your income decreases, what happens to the demand? Decrease in demand. So here in shift, you will notice that price will remain constant, but other factors can change, like your income can increase and decrease, so your demand will change. Let us see other examples. I have given another one. Price of substitute increases. Let's understand this. Price of substitute increases. Substitute goods, tea and coffee. Let us say you are drinking tea and the substitute good is coffee. The price of substitute good will change. Let us say the price of the substitute, that means coffee, increases. Coffee is now relatively more costlier. If the price of the substitute good coffee increases, what will happen to the demand for tea? It will increase. There will be increase in demand for tea. Why? Because people who are drinking coffee will find that the substitute good coffee is very expensive and they switch over and start drinking tea. Similarly, if you see here, price of substitute decreases. Substitute goods, tea and coffee. If you are drinking tea and coffee is the substitute and the price of coffee falls, decreases. So what happens is tea will be relatively costlier or coffee will be relatively cheaper. Some of the consumers who are drinking tea finds coffee cheaper and they switch over. When they switch over to coffee, demand for tea will fall. This is what the idea is. If you want to take another example, you can take, For example, price of complementary goods. Complementary goods example, petrol, petrol cars. Let us say price of petrol falls. Price of petrol falls. If the price of petrol is cheaper, what will happen to demand for petrol car? Obviously, when there is a fall in the price of petrol, demand for petrol car will increase. That means if you want to take an example in increase in demand, you have to say price of the complementary good will decrease. Price of petrol, if it decreases, then there will be increase in the demand for petrol cars. Similarly, if you want to take price of complementary goods like petrol, price of petrol, if it increases, what will happen? Demand for petrol car, it will decrease. There are other many examples which I will do in detail in the later chapter when you need it. Notice the whole demand curve shifts. Notice again the whole demand curve shifts. Now let me explain to you in a diagram. Let's have a look. So here it is, we are doing shift. On one side there is increase in demand and there is decrease in demand. Not increase and decrease in quantity demanded, because shift means increase in demand, decrease in demand only. For the first case, you know price is constant, no change in the price, price is same. Here also what happens to the price? Constant, no change in the price. What changes is other factors. Other factors change. Example, other factors change, your income increases. Other factor change here, let us say income decreases. Let's see. Price is same. If your income increases, what happens to your demand? There is increase in demand. There is increase in demand. Whereas here, when your income decreases and price remaining constant, there is decrease in demand. Now, let's have a look at the graph. This is your price. This is your quantity demanded. Your demand curve, DD. This is your price. This is your quantity demanded. Now what happens? Make sure your price will remain constant, no change in the price. Price will remain same. But still there should be increase in the demand. How can your demand increase? Your demand can increase if only if the demand curve will shift. D1, D1. So what's happening here? Let's see. Price remains constant, no change in the price, same price. You are here, now you moved here. Q1. Price remain constant, your income may have increased. What happened? There is an increase in your demand. Similarly, if you want to see this, this is your demand, DD. This is your price. This is your quantity. Now, price has to remain constant. Your income has decreased. If your income decreases, what happens to your demand? It should decrease. You have to come this side. To come this side, you will have to have D1, D1. Where does it meet? Here. New price meets here, Q1. Price remain constant. There is decrease in the demand. Finally, let's have a look again. Here what's happening. The whole demand curve is shifting upwards, upwards and rightwards. Upwards and rightwards. Whereas here, the whole demand curve, the entire demand curve shifts downwards and leftwards. So you have to write the entire demand curve. What happens? Shifts. Which side? Upwards and rightwards. Upwards and rightwards. Here, the whole demand curve shifts leftwards and downwards. Notice that when you write this, for example, in ISC, if there is a question, explain the shift in the demand curve or differentiate between increase in demand and decrease in demand, kind of alternate question comes. What you need to do is, step 1, write price constant, other factors remaining, other factors will change. Example, income increase. What happens? Increase in demand. Then draw your diagram. Half mark for this, half mark for this, half mark here, and the final half mark, half mark. Half, 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 this is 3 marks. So in the choice section, 3 marks question might come. Each is half mark. So your diagram is important. And finally, you have to write here, the entire demand curve shifts upwards, rightwards. The entire demand curve shifts leftwards, downwards. Note, it's very important that you show your arrow. Arrow has to be shown in your exam. Arrow has to be shown. Your arrows are very important. You need to show your arrows. Always have your origin, y-axis, x-axis written. Always write your price and quantity demanded so that the answer will be perfect. So now you've understood what is shift in the demand curve. After this, I'll just give you an idea about what is elasticity of demand, because I will be explaining it to you in detail in the next class. Now, elasticity of demand, elastic, stretchable, like a rubber band. It will stretch. Now, elasticity of demand means, for example, we say when the price increases, demand decreases. But by how much? How much it will decrease? For example, if the price of, say, potatoes increase by 10 rupees, then the quantity demanded will decrease. But by how much? Price elasticity of demand is what we will talk about here. Price elasticity of demand here actually means that if there is a change in the price, how much will the quantity demanded change? For example, if the price increases by 10%, then the quantity demanded may also decrease by 10%, or it may decrease by 50%, or there will not be any decrease in the quantity demanded. How much will the demand change when there is change in the price? So elasticity of demand is the topic. In elasticity of demand, there are some parts you have to do. The first one is price elasticity of demand. Then you will learn income elasticity of demand. And the third one you will do is cross elasticity of demand. The first thing I am going to teach you is price elasticity of demand, which actually talks about how much the quantity demanded will change if there is a change in the price. Sometimes the price will increase, but the quantity demanded will not change. Sometimes price increases a little bit and quantity demanded will change by a huge amount. So how much it responds, please learn. It is the degree of responsiveness of quantity demanded of a commodity in response to the change in demand. So here there is a slight, it is the degree of responsiveness of quantity demanded of a commodity in response to the change in, this is a mistake here, it is not demand, please correct it, this is price. Okay? So it is the degree of responsiveness of quantity demanded of a commodity in response to the change in the price. Okay? I am going to explain in detail about elasticity of demand in my next class. So this is all for today. We'll come back again. Hope to see you in the next class. Thank you so much.
Hello everyone. Welcome to the next episode of Computer Science for ISC 2021. We are dealing with Boolean Algebra, so we'll continue with that. Okay. So let's focus here on the screen. So we are dealing with Boolean algebra. We will be solving a problem. Okay, our expression is given p plus q complement, p plus r complement, rq. So we are supposed to draw the truth table and logic diagram for this given expression. P plus q complement and p plus r complement added with rq. Okay. Now you must remember that when you are solving an expression, first you should solve the complement, the not. Okay. Then whatever is within the bracket. Then comes the dot operator, the AND operation. And then will come the plus or the OR operation. Fine. So let's do this. Now I've created the table already. So there will be around 10 columns. Also remember that looking at this expression, we can make out that there are three different literals. P, Q, and R. Okay. So three literals. Remember the formula 2 to the power n, where n is the number of literals. So here we have got three literals. So 2 to the power 3, that is 8. That means there will be 8 different combinations. So 8 different combinations. So let's write down the three literals P, Q, and R. Now remember, for this leftmost literal, half of the combinations will be 0, half will be 1. Because we have got 8, so half of 8 is 4 zeros, 4 ones. So P has got 4 zeros, 0, 0, 0, 0, then 1, 1, 1, 1, 4 ones. 4 zeros, 4 ones. Q will have half of this. That is 2 zeros, 2 1, 2 zeros, 2 ones. Fine. And finally for R, which is on the extreme right, alternate. 0 and 1 will alternate. So we got 0, 1, 0, 1, 0, 1, and 0, 1. So we have got the three different literals and the 8 different combinations of the zeros and 1 of the states. Okay. Next, we need to solve the complement. So first comes Q complement. So let's solve Q complement. Q complement will be reverse of this, reverse of Q. Complement, remember, reverses. 0 will become 1, 1 will become 0. So when we do this Q complement, it becomes 1 1 0 0 1 1 0 0. Reverse of this, 0 0 has become 1 1. 1 1 has become 0 0. Again 0 0 has become 1 1. 1 1 has become 0 0. Right? Now we will solve this portion, the bracket P plus Q complement. P plus Q complement. So that is P is this column, Q complement is this column. So we will use only these two columns. The middle two columns are not required. So P plus Q complement. Plus means OR gate. We are using the OR gate. In case of OR gate, if any of the literal has 1, the output will be 1. Only when both the literals are 0, the output will be 0. So 0, 1, 0, 1, 0, 0, 0, 0, 1, 1, 1, 1, and 1, 0, 1, 0. Okay. So this is what we get. If you look carefully, 0, 1. This literal is 1, so output is 1. Again in this row, there is 1 is there, so 1. Here both are 0. Both the literal values are 0, so it is 0. Similarly in the next row, both are 0, so output is 0. In the rest of this, you got 1 in the literals, so all will be 1. So we got 1 1 0 0 1 1 1 1. So this portion is solved. Now we move to the next one, P plus R complement. In that first we need to solve R complement. Okay, R complement. So reverse of R. R is 0 1 0 1 0 1. So complement of that becomes 1 0 1 0 1 0 1 0. Okay. So now that we have got R complement, now we will solve what is within the bracket, that is P plus R complement. P plus R complement. So P is this column, R complement is this column. So we will be concentrating only on this column and this one. Here also we are using the OR gate. plus sign, OR gate. So if any of the literal value is 1, the output value will be 1. So based on this, first row, we've got 1 there, 1 is here, so output is 1. Second row, both are 0, output is 0. Third row, there is 1 here, so 1. Fourth, again both are 0, so we have got 0. Fifth, 1, 1, 1. Sixth also 1 is here, 0 is here, so 1. Sixth one, we have got 1, 1, 1. And the last one, 1, 0 is 1. Okay? So now we have solved this one, we have solved this one. Now we solve this bracket. So R, Q. Okay? R plus Q. Not R plus Q, R dot Q. R and Q. That is the AND gate. In case of AND gate, remember, when we speak of the AND gate, if both the literal values are 0, it will be 0. If either of them are 0 or 1, it will be 0. Only when both the literal values are 1, only then the output will be 1. Okay? So we are dealing with these two columns, R and Q, or Q and R, same. So 0, 0, output is 0 here, if you look here. Then you got 0, 1, next one is 0. 1, 0 is also 0 here. Then we have got 1, 1, which is 1, because both are 1, we are getting 1. Next we have got 0, 2 zeros, 0, 0, 1 is 0, 0, 1, 0 is 0, 1, 1 is 1. So only in 2 rows we have got 1. This row both are 1, and this row, last row is 1, 1. So we have got 1 here, we have got 1 there. Fine? So we have solved whatever is inside this bracket, whatever is here in this bracket, and whatever is inside this bracket. We have solved these 3. Next comes these 2. The gate here, nothing is mentioned here, that means it is a dot operation. Dot operation means AND gate. Okay? So P plus Q complement ANDed with P plus R complement. That means we are dealing with this. P plus Q complement is this column, P plus R complement is this column. So within these 2 columns, we will be using the AND gate. AND gate, remember, when both are 1, then the output is 1. In all other case, it will be 0. So first row, if you see, first row we have got both as 1. So output is 1. Next 1, 0, 0, 0, 1 is 0, 0, 0 is 0. Again in this row, this column is 1, this column also has got 1. Both are 1, so output is 1. And for the next 3 also, you will see all 3 are 1, 1, so output is 1. So last 4 rows we have got 1, and the very first row is 1. Second, third and fourth we have got zeros. So now we have solved this one and this one. So now we have to solve the whole thing. Now when we do the whole thing, this whole expression will not fit in here. So what we do is, we can assume this part of the expression as A and this as B. Okay? So here we are writing now A plus B. A plus B. A is this one, B is this one. So A plus B, this whole expression. Okay? So between A and B we have got the OR gate. OR gate means if any of the column is 1, output will be 1. Only when both are 0, output will be 0. So now we are dealing with A and B. Fine? These 2 columns. So 0, 1 is 1, 0, 0 is 0, 0, 0 is again 0, 1, 0 is 1, 0, 1 is 1, 0, 1 is 1, 0, 1 is 1, 1, 1 is 1. Only in these 2 rows, this one and this one, both the literals have 0 values. So output is 0. In all other case, it will be 1. So final value is this column, 1, 0, 0, 1, 1, 1, 1, 1. So this is your truth table for this expression. Clear? So now we move on to the logic diagram. When you are drawing the logic diagram, again complement should be solved first, then what is within bracket, and then comes the AND portion, AND gate, then comes the OR gate. Okay. Also, even before complement, if there is something within the bracket, of course, bracket will be done first, right? We'll start from left, so complement, Q complement will be done before anything else. So we have got 3 complement, P, Q, and R. So here we have got P, this line is P, this line will be P complement. This is P, this is the complement, this is the NOT gate. So connection coming out from P, going through this NOT gate becomes P complement. So P is this line, P will be, P complement will be this line. So P and P complement. Similarly, Q and Q complement, R and R complement. We are using this method because this is easier to understand. Fine. Even if we don't require P complement, we have just taken a line out, which will not be used in our diagram. Next comes P plus Q complement. We will solve this portion, P plus Q complement. So we take a line out of P. Remember, this is P. So we have taken a line out of P, and we need a line out of Q complement. So this is Q complement. So line out of Q complement. So here we have got P, here we have got Q complement. Now between P and Q complement we have got this OR gate. So we draw the OR gate. So between P and Q complement we have connected P and P complement with the OR gate. Fine. So this portion is done. Now back to next one, P plus R complement. So we draw a line from P. Remember, this line is P, so I've taken a connection out. Then comes R complement. If this is R complement, so we have taken a line out of R complement. Now between P and R complement we have again got the OR gate. So OR gate between P and R complement. Fine. So we have solved this portion, we have solved this. Now between these two we have got the AND gate. The AND gate between P plus Q complement and P plus R complement. So these are the OR gates, this is the AND gate. So this portion is done. Now comes this one, RQ, that is R dot Q. So R is here, Q is here. This one is R, this one is Q. So R and Q. Now R and Q, we have got the AND gate. So AND gate between R and Q. Here we had the OR gates, here we have got the AND gate. Here between these two we have got the AND gate again. So this portion is done, this portion is done. Now between this and this we have got the OR gate. That means between this and this we will again have the OR gate. So we take the connection out and bring it nearer, and then we draw the OR gate. Okay. So this is your logic diagram for this expression. Remember, there are different methods of solving this. We have used this. This is an easier method of solving or drawing the logic diagram. Okay. So we have learnt to draw the truth table and the logic diagram for the given expression. Fine. So we will stop here today. We'll continue with this in the next episode. In the next episode, we will either deal with one more expression or we will move on to the sum of the product and product of the sum. Okay. So as I usually say, the same thing, stay at home and stay safe during this pandemic. We are here to look after your classes. Thank you, everyone.